Okay, did you do your homework? I hope so. Let's check your results. Let's start off by going to the simpler version of this challenge where we're just going to count up how many times each movie occurs in our dataset as opposed to each individual rating type. So let's go off to our terminal prompt using SSH or PuTTY and have a look at how I did that. So let's start off with the easy version of this challenge where we're just going to change our existing script to count up how many times each movie occurs in our dataset as opposed to each rating. So to do that, let's just edit the existing ratings breakdown.py script that we have from before. So I'm going to type in nano ratings. Wow, I really can't type this morning. There we go. All right, so really all we need to do here is extract the movie ID instead of the rating, right? All we want to do is count up a different thing. So it's just a matter of going into our first mapper here and changing that to yield the movie ID and the number 1, which will then get counted up by our reducer. And what we should get here is a count of how many times each movie was rated in our data set. So let's hit Control O to write that out, and hit Enter to accept that file name, and Control X to get out. And now we can just run it. I'll just run it locally to make it simple. Python ratings breakdown.py u.data. So that's all you had to do this challenge, and there's our results. So, like we talked about, this is real data. You know, we can see that movie ID 99 was rated 172 times, but it's not terribly useful. What we really want to see is what are the most popular movies and the least popular movies, and it's not sorted the way that we want to do that. So, let's go look at my implementation of how I actually wrote the code to sort these by count instead of by movie ID. So here's a more nicely formatted version of my script that actually solves the sorting by movie count problem. And again, we'll take another look at this more closely. So go through this line by line. We start off by importing mrjob and mrstep. You'll need that in every single mrjob script you write in Python. And, we could have changed the class name, I guess. If you want to, you can, but it doesn't really matter in this case. Inherits from mrjob. And we're setting up, again, 2 steps here. One that includes the mapper and reducer like we did before, and this mapper is going to extract this time the movie IDs and the number 1, and the reducer will count them all up together. And what we're going to do differently in this reducer is output things such that the sum of the movie counts is the key and the movie ID is the value. That way, when we pass it through a second step, the shuffle and sort phase will automatically sort things by the movie count for us. And all we have to do is iterate through every movie for each unique count and print out the results. So that's what the rest of the code does. This mapper is similar to what we did before. We're just splitting out the input line by tab characters. But instead of outputting the rating, we're going to output the movie IDs because that's what we want to count up first. So the thing that we want to aggregate on is our key. And in this case, we're aggregating on the movie IDs. Then our reducer gets a list of every single list of ones associated with every movie ID, and it adds them all up together using sum. Okay, and now to make sure that it sorts properly as strings, we convert that sum to a string and zero fill it to 5 digits so that it sorts properly when treated as alphanumeric characters. And the key that we're outputting the key as the value here. So we're switching things around, right? So we're putting the count first because that's what we want to sort by, and then we're going to put out the actual movie ID, which is the key coming in. Okay. Now again, you can call these variables whatever you want. That tends to confuse a lot of beginners. I could call that Fred and Tom, and that would work just fine as long as I said some Tom and then Fred here. But, just keep in mind there's nothing special about these names. You can name things whatever you want. And finally, in the second step, after things have been shuffled and sorted, we can print them out in our final reducer in the second stage. And this time, what we're going to get is each unique count that occurred in the data and all the movies associated with that count. So if we had more than one movie that had only 1 rating, for example, we'd get all those movies here. So we need to go through each one of them, and that's what this code does for movie in movies. That basically iterates through every movie in the movies list and prints them out individually. So we're going to yield each individual movie and the count associated with that movie. And then this little bit of boilerplate down here just runs it, kicks it off. So let's go back to our terminal and actually see it in action. All right, I hope you had some success in actually sorting these using the tips that I gave you in the previous lecture, but if not, you can download my solution to it and actually run it if you'd like and examine it. So I've made that available on my website. So you can just type in wget http://media.sundog-soft.com/hadoop topmovies.py. And again, pay attention to every little dash, every little punctuation, capitalization as well. The T and M should be capitalized. And there we have it. So we can take a look at that. nanotopmovies.py. And here it all is together. So you can see, like we talked about, we actually have 2 steps in this job. So what we're going to do is leave our mapper and reducer as it was before when we just counted up the individual movie counts, but then we're going to send that through another step. And the purpose of that is to actually take advantage of that second step's shuffle and sort phase to actually sort things the way we want. So the trick is our first mapper is pretty much unchanged from the easier version of this challenge. We're just outputting movie IDs and the number 1 for the key and value for each input line. Then our reducer is actually making the keys the counts, but formatted in such a way that they will sort properly numerically. So again, what we've done here is we've taken the sum of the counts for each individual movie, we've converted it to a string and zero-filled that to 5 digits, okay? That way it'll sort properly when it's treated as a string. And then when we send it through another stage, another step in MapReduce, that goes through shuffle and sort, which ends up as a byproduct sorting everything by that first key value. So we end up sorted by count, and then all we have to do in our second stage's reducer is print out the results. So we can just say for the list of movies associated with each unique count, we're going to go through them one at a time and print out each individual movie and the count that it was seen with. And let's see if this actually works. Just Control X to get out of here. And again, we'll just run it locally for now. Python top movies.py u.data. And we're done. So you can see we have the same answer as we had earlier in the course. Movie ID 50, Star Wars, is still the most popular movie with 584 unique ratings. And the second most popular is Movie ID 258. If you're curious what that is, go open up the u.item folder from your Movie Lens download and check what that might be if you're curious. Later on, we'll tie things together. Now, there's a lot more we could talk about with MapReduce. We've kind of scratched the surface. For example, there's a way of passing ancillary data around, so we could actually have a dictionary that would actually map those movie IDs to movie names to make it more readable. But again, we don't want to go into too much depth in this course. You know, the main thing is that I want you to understand the concepts of how MapReduce works, because it is a fundamental concept that we'll keep seeing again with other technologies that are more in vogue these days. But even things like Spark have the concept of mapping and reducing, so you need to understand that in order to really grasp Hadoop and the larger ecosystem. All right, congratulations. You have now tinkered with MapReduce for real and actually run it with Hadoop. So if you want to do a little bit more exercise here, I do encourage you to actually run these using Hadoop. Again, you need to use the -r Hadoop option and pass in where the streaming jar is like we showed you before. So there you have it. If your goal was just to understand the core of Hadoop itself, well, you've achieved that goal. We've actually messed with HDFS and MapReduce and solved some real problems using it. But don't stop now. MapReduce was just the beginning with Hadoop, so there's new technologies that we're going to talk about next. Let's dive into Pig and Spark and actually learn how to actually write real scripts and actual more performant programs on top of your Hadoop cluster. We'll do that up next.